of Good morning and welcome to the webinar on CAD/CAM and CAE with a focus on CAD. So first of all, on behalf of Amrutvahini College of Engineering, Department of Mechanical, I welcome you all for this particular webinar. My sincere thanks to Nitin sir, who is Director of Deccan IT Solutions, for his consistent support in organizing the various programs related to use of Mastercam and allied modules of it for Amrutvahini College of Engineering. In this particular webinar, uh, the contents which will be covered includes starting from the CAD/CAM and what is the role of this particular CAD/CAM engineer scope. All these things will be covered by Nitin sir, and along with that, the major focus will be on how to use Mastercam for toolpath generation and manufacturing simulations. So I welcome you all, and I'm sure that this particular webinar will be useful to all the students, to not only to perform their academic practicals, but to get more details into this particular CAD/CAM applications, and getting to know about what are the different opportunities and avenues in their career. Good morning and welcome to the webinar on CAD/CAM and CAE with a focus on CAD. So first of all, on behalf of Amrutvahini College of Engineering, Department of Mechanical, I welcome you all for this particular webinar. My sincere thanks to Nitin sir, who is Director of Deccan IT Solutions, for his consistent support in organizing the various programs related to use of Mastercam and allied modules of it for Amrutvahini College of Engineering. In this particular webinar, the contents which will be covered includes starting from the CAD/CAM and what is the role of this particular CAD/CAM engineer scope. All these things will be covered by Nitin sir, and along with that, the major focus will be on how to use Mastercam for toolpath generation and manufacturing simulations. So I welcome you all, and I'm sure that this particular webinar will be useful to all the students, to not only to perform their academic practicals, but to get more details into this particular CAD/CAM applications, and getting to know about what are the different opportunities and avenues in their career. So I welcome you all again for this particular webinar, and my sincere thanks to Nitin sir and the whole of his team of Deccan IT for organizing this webinar. Thank you.
Good afternoon, everyone. Let me introduce you to Mr. Nitin Vakode, Director of Deccan IT Technologies, Skyleap Technologies. He has completed his graduation in BE Production Engineering, post-graduation in ME Mechanical with specialization, PhD in pursuing in CNC machining parameters of optimization area. Areas of experience: Industry 4.0, robotics, CNC manufacturing, product design and tooling development, stimulation. Total industrial experience is of 24 years, 2 years as a director with Deccan IT Technologies, Skyleap Technologies, 13 years, that is to July 2005 to April 2018 with Onwards Technology Limited, Associate Vice President PSG. 8 years, that is August 1997 to July 2005 experience, German tool, Room Aurangabad in German precision and tooling manufacturing. 1 year, that is July 1996 to July 1997 with Aditya Birla Group, CNC manufacturing in hardcore expertise in CNC, programming and manufacturing, CNC milling, 2 to 5 axis milling, turning, Mastercam programming, CAD, CAM and CAE, knowledge about cutting tools and its parameters, CNC controller programming, programming for various machines like DMG, HAAS, Fager, Thermwood, BFW, Jyoti, Okuma, Mitsubishi. Metrology CMM expert, domain expertise in plastic mold manufacturing, sheet metal dies, casting dies, component development, robot programming, expertise in executing CAM projects using Mastercam, UG, NX, CAD and CAM, Vericut, CATIA V5, SolidWorks, NC, CMU. International exposure for business, seminars, training in USA, Germany, Italy, UAE, Sri Lanka, Saudi Arabia, Qatar and Malaysia. As extracurricular activity to support academic, actively involved in providing technical lectures, training, curriculum development, CAD, CAM and CAE manufacturing with Indo-German tool room, CITD, GTTC. Supported Board of Studies, Savitribai Phule University, industry member, Raisoni College of Engineering, Waguri, Pune, BOS member, Vishwakarma University, Pune Management Studies and BOS member. Certifications in plastics and mold design, certification GTZ Germany, CMM inspection, Carl Zeiss 6-week training, SolidWorks certification, AVA certification, Vericut certified to iOS auditor. Thank you.
Thank you. So, friends, basically, I should first thank you for your patience for waiting so long. We had a technical glitch here with the internet, so we're not able to start on time. Okay. So on your screen, you could see that there are some complex machines, certain complex parts of port or manifold. Nowadays, the designs are becoming more and more complex. Not the way it was earlier designs, where the designs were like boxes or shapes which were very, very simple in shape. With the change of taste of customer, it has been a challenge for the companies to manufacture the parts or design the parts the way customers like, and the product life cycle is also very, very short. So in order to meet this requirement, there is a lot of pressure on the industry to design it in a shortest time, and manufacturing is also in the shortest time. So if in case the conventional manufacturing keep on happening, the manufacturing cycle will be too long. That's the reason the introduction of Industry 4.0 has come into place, where SEAM has also a greater role, because even if somebody designed the part in a very short time, but he is not able to manufacture that and deliver, so there is no use. The customer will not be able to get the products what they are expecting. The days are gone when the same product, once launched, was used to be there for almost 5 years, 10 years, something like that. If you see the examples, like Ambassador had a same model for many years. Premier Padmini had a same model. Even the foreign manufacturers those days used to have the same. But now the scenario is changed. Almost every year, every manufacturer is launching 2 to 3 new models. Okay. So that's the reason with the digitization, Industry 4.0, all this are supporting, because of the computational power of computers and internet connectivity. That is possible to get the parts like sync. Let's say one part is getting manufactured in Malaysia, the tire from Goodyear's Malaysia, or some parts are getting manufactured in China, Shanghai factory, or Shanghai factory, or some parts are getting manufactured, engine part, maybe a critical of BMW may be manufactured at the Stuttgart facility in Germany. So it depends, and some styling must be done in Italy. So all such thing has to be done. So this industry 4.0 help you in getting this all sync. So the manufacturing has a lot of important role in this industry 4.0 in today's scenario. So we'll see that how the software what we are discussing today is going to help achieve that kind of a results. Okay. So first of all, we'll just have a look at the history, how the software has evolved, how it is manufactured, how it is developed. Okay, and then we'll have a look at the software itself directly with the hands-on.
Some of the parts that we did, we were taking old programs that we were running for years and changing them from 40 minutes to, in some cases, 22 minutes. Almost a 50% increase right off the bat.
The biggest problem we got right now in roughing out these billet blocks is the chip conveyor won't keep up.
Biggest reason to use Mastercam? Flexibility. You wouldn't believe what the energy industry can throw at us. What used to take the clinician 8 to 12 hours, now we're using Mastercam to turn that time around into 1 or 2 hours.
Thank you, everyone. Yeah, hope I'm audible to you. Yeah. So now this is once again I would like to welcome you this technical webinar on CAD/CAM software, that is Mastercam, and we at Technical IT Technologies welcome you for this session. Okay, we are authorized reseller for Mastercam in India, and almost all academic institutions who are using Mastercam are definitely proud to have this software with them. Here we can see the globe and the cutter. So it's something like that. Mastercam is cutting almost everywhere in the globe. Reason is that almost close to 200 countries in the world are using Mastercam, and that's the reason it is almost since last 24 years it is number one in the world. So what Mastercam or what CAD/CAM actually it is? It's a CAD/CAM. It's a tool which help you generate, get the CAD model from the CAD software or develop a CAD software in the software here itself, and help you produce the things which are required as per the required tolerances, shapes, geometry, all such things. So this is a single platform which will help you manufacture on milling, turning, wire idiom, router. Even the robotic machining is possible with Mastercam. This is the simple reason that there is a huge demand in market with the program. If you are a programmer using Mastercam, so the employability becomes easier. Another aspect is that many of the people say that no, I don't want to do the career in CAM. I would like to go in a CAE or maybe in a CAD. That's okay. It all depends. But one has to understand the concept. Like if a part is to be designed, we must understand the concept behind it, like whether it will be manufacturable or not. And if you are not able to make a difference between manufacturable and non-manufacturable, the product you design will never be able to manufacture, or it will take a long time to manufacture, because the ease of manufacturing has to be considered in the design. So even if you are a designer or even if you are a CAE engineer, so you must have a concept of understanding or of manufacturing, manufacturability, all such things. So it's very important to learn it during your academics itself, so that you don't waste your time after you complete your graduation and doing a job. That time again you realize that, oh, this link is missing in my academics, I must complete that. Fortunately, University of Pune has given that in your syllabus itself. So some part of it definitely you must be learning, but I'm not sure how much you are learning. You should try to learn most of the concept of it, so that once you graduate, later on you should not have that missing link. Okay. So here, if you can see advantages, we all know that there is a effective utilization of raw material, productivity rate is very, very high, costly mistakes and all that such accidents are eliminated, and precision what is required can be achieved on the CNC machine, because this is nothing but computer controlled machines which are controlled using the NC programs which are created by the CAD/CAM software. So it will behave the way the program is, strategy is there, or it is programmed. Okay. So what Mastercam does, it has got like a design module to design a part, modify the part, create certain clamps, anything. Though definitely design is not as strong as the other CAD software like the Siemens or Creo or Katia, because the software Mastercam is master in CAM. That's why the design capabilities are limited, but sufficient to help you do certain clamps, modify the parts. Even the modeling of the parts are possible to a large extent. 2D 3D machining is available where the CNC milling can cut the parts for different applications like die and mold and etc. Lathe machine with exact axis. Here I don't know students how many, I hope everybody is familiar with the axes like X, Y and Z. When you talk of milling, the spindle is most of the time it is Z axis, Z axis or Y axis in horizontal cases. Okay, and XY is like on right hand side of your hand. If you do, extend your hand, that's your X axis, and if you look towards machine, that's Y axis, and the vertical upward to downward is Z axis. So such, and in case of lathe there are different this one, because there is a Z axis in the spindle axis and X axis which is 90 degree to it, so it is a spin axis. Okay, in multi axis it is X, Y, Z, C axis or A axis or B axis. The machine which is in front of you is a 5-axis machine, so it has got A and C axis. The rotating axis which is along the Z axis is called generally C axis, and the X axis along there is A axis, so that is A axis. So this machine has got a A and C kind of a combination. There is a wire radium machine support available, wherein it's a non-conventional kind of a machining where the wire radium wire at a very high temperature zone. Because of the electric discharge, there is a certain amount of discharge of electrical, so that happens within a short span, and that spark is continuously happening with intermittence and keep on burning the material there. So a very thin wire of 0.1 mm, 0.2 mm or 0.25 mm, which is usually coated, molybdenum coated or tungsten coated or brass coated. So all such coatings are there in order to improve the effectiveness or efficiency of the wiring machine. So that support is also available in Mastercam. And there is another application called router. The router is for cutting multiple parts from the large sheets, usually for aircraft various parts manufacturing or helicopter part machining, or even the different machineries, equipments or sheets required. So the router is used. Even the woodworking, for woodworking different applications you can utilize a router. So as we already discussed, design is a good amount of features are available like wireframe, surfaces, solids, modifying it, all such features, but limited to the requirement of the manufacturing. Milling, as we discussed, like 3-axis VMC, HMC, 4-axis, 5-axis. Okay, now there is multitasking machines, so it can generate tool paths which can be used for the turbine blade machining, die and mold machining, cavities machining, aerospace components such as structures of the aerospace, defense sector machine parts. So all such parts can be machined, and the benefit is that the parameters which are given in Mastercam menus are very simple to understand, and you can easily use that and program. It has got a features for the programming probe. It's on machine inspection. You can machine, immediately check, and again machine if there is any deviation. So all such good features are available. Tool libraries are there, operation libraries can be done. There are now this is the turning machine which is in front of you. There is a, on the spindle there is a job attached, and there is a turret on which there is a tool. So it is a top turret type of machine. The conventional machine is usually bottom turret. So this it has possible to have bottom turret, top turret both. So this machine is shown as a top turret. There are machines, even the VTLs are also available, vertical turning lathes, where if the part size is huge, like a railway wheel or maybe a large your satellite vessel outer ring, which is to be machined. So huge components cannot be turned on the horizontal lathe, it has to be machined on the vertical lathe. So we have got certain such at even VSSC, ISRO centers where we are giving them a solution for such VTLs, where even in one of the case the turret is so huge that on turret itself there is a controller and the space for operator to stand. So operator is standing over there, he can move from there to the main area. So, and the speed of this rotation is very slow, maybe one rotation per minute, because the size are also huge. So such complex machines are also supported by us, and we would like to show you some industrial as well as educational users who are proudly using. I think one of them is also Amrutvahini College of Engineering. Yeah, and here you can see that Army Base workshops are there, advanced training institutes are there, Bharat Dynamics is there, Bharat Electronics is there. There are various engineering colleges, railway workshops are there. You can see a lot of University Pune, University colleges as well. All the NTTF centers are users, all Indo-Danish tool room, Indo-German tool room. Yes? Sorry. Yeah. So BARC Mumbai is there, HAL is there, CTTC, GTTC, okay, GTRE, this gas and turbine research establishment. Okay, ordnance factories are there, and recently we also received one award for the best educational partner in India for achieving the highest business and supporting maximum customers. Okay, so now what we'll do, we'll have a look at the direct interface. So Akash will show you a certain operation which will help you directly go through the software. Most of you might have seen in your institution, because you already, some of you might not have seen. So you can have a look at. He will explain you in detail. Okay, handing over to Akash. Akash, please.
Thank you, Nitin sir, and good morning to all of you. So as you can see that first machining operation in mailing, so we have to do first face toolpath or facing operation. So this facing operation, we need some basic parameters. Okay, so what is face toolpath? Like in this toolpath, one can quickly clean the stock from the top of the part and create an even surface for future operation. You can pass the toolpath or either change geometry or on the current stock model. So there are some given basic parameters like across, along overlap, approach distance, exit distance, and step over. Similar to that, for the facing operation, you will get some types of facing toolpath like zigzag, one way, and dynamic, and one pass. This is the toolpath way. Okay, so given side there is a simulation video for the facing toolpath. You can see, and just playing that. Okay, this is our facing operation, and this toolpath is like a zigzag. Okay, so let me show you the Mastercam Interface 2020. As you can see, there is a model, existing model. On this existing model, I have to create facing operations. So first of all, for the facing operation, So we have to do first stock setup. Okay, for the stock setup we have to go to the toolpath manager. In this toolpath manager you will get properties, and in this properties you have to set the stock setup. For the stock setup we have to select the all entities, and after that give the value of Z for the facing. Okay, I have given that and display that. After that click on OK. After that, after OK, you will get the wireframe stock. Okay, this is our extra Z value 2 mm. And after that go for the operation from 2D toolpaths. Here you will get so many of toolpaths like contour, drill, dynamic mill, facing, dynamic contour, pocket, fill mill. There are various type of toolpath in 2D. Okay, so first face, after click on the face toolpath, you will get a window for the chain selection. Okay, here we will get so many type of method for the selection, and we have to select the chain. After selecting the chain, you have to click on that. Okay, and okay, and after that you will get a window of 2D toolpath facing, and according to your application you have to select the toolpath type, which toolpath you are doing now. So I have to do facing, so I have selected face, and from next we have to select the tool. In this tool you can see that there are various types of parameters like tool diameter, corner radius, tool name, tool offset, length offset, head, diameter offset. There are the various cutting parameters, tool parameters are there. Okay, according to your application you can given the value of tool parameters or cutting parameters. And in this comment box you can write anything to for the operator, like this for example I'm writing here that facing width as for my tool that I am using that or I will use. Okay, so for the tool you have to go to the standard tool library. Go to the standard tool library, you have to click on this select library tool. After select library tool you will get there are a lot of tool. Okay, if you want to filter that you can also filter. So after selecting filter I just got a face tool of 50 diameter and click on OK, and you can modify also that. On the right click of the tool you will go for the edit tool, and here cutting you will get cutting diameter, secondary diameter, overall length, cutting length. Okay, and which type of corner type you have on your tool you can give also that. After that finish on that, and just in comment I have just writing that facing with 50 mm tool. Okay, and coming to the next in holder, as for your facility or as for your availability of holder you can select the holder. Okay, I have selected BTC30016. And coming to the next parameters, in cutting parameters you will get the style that I have told you in PPT, that you will get there are 4 types of style like zigzag, 1x1 pass, dynamic. Okay, basically the most preferred is zigzag, preferable style is zigzag, and here we will get the across overlap, along overlap, approach distance, exit distance. Okay, and step over also. After that here you can see that climb and conventional like up milling and down milling. And after that if you want to stock to live on floors, then you can give that value or 0. Okay, after that coming to the depth of cuts, in depth of cuts you can provide your depth of cuts value, like I am just providing 0.5. After that keep tool done. If you are selecting this keep tool done, then your tool not repeated time for the retraction or clearance. Okay, and coming to the next in linking parameters, this is the most important parameters. So in the linking parameters you have to select clearance, you can give the value of clearance, and all you have to set in absolute. Fit plane it's okay with incremental, and depth also in absolute. Okay, So as you know that it automatically select the top of stock. As you know, we have given the z value plus 2, so it automatically generate that 2, and after that we have to select we have to just OK on this, and you will see the toolpath here. Okay, this is our toolpath, and this is our along overlap, this is our across overlap. Okay, so let me show you the 2D toolpath of this facing operation. Click on this back plot and you will get the 2D toolpath, how it generated, and play. Just see that how it cut that material for the facing toolpath. This is our 50% across overlap, this is a along overlap. Okay, and if you want to see in this 3D simulation window, then you have to go for this verify, and after the selecting this verify, you will get another window for the simulation. Okay, as you can see, this is our 3D simulation window, and just decrease the motion of the tool, cutting tool, and in this window you will get so many informations like move ID, move type, and what type of operation that you are doing, and operation name, which type of tool that you are using. Okay, there are various type of information that you will get. Okay, this is our simulation window. Let me start the operation. As you can see, the tool is coming downward and cutting as per our given depth of cut, given style, the cutting method. So this is it our for the facing operation. Okay, and if you are talking about the ANSI code generate, how it generate, then for the ANSI code generating, you just have to click on this post selected operation, that G1 on G1. Just click on this, and for post processing you have to click on the ANSI file and OK, and after the OK he will ask for the root where the file will be saved. Okay, and I just that will be on the desktop and save. After that you will get a Mastercam code expert window, or in this code expert window you will get your ANSI code, all the ANSI code as per your commit. You will get this, just see. Okay, mail face pocket ring, this is our all ANSI code generated. Okay, thank you. So coming to the next toolpath is our pocket toolpath. So basically this toolpath is used for the clean out material from enclosed boundary, reducing the specified depth of cut. So basically this toolpath is used for the roughing purpose, and here similar to the toolpath, there are some basic parameters like rough cutting methods, step over percentage, entry motions, and depth of cut, or linking parameters, etc. So as you can see, there is a simulation video for this pocket toolpath. You can see the cutting method of this pocket toolpath, how it will cut that material from the workpiece. Okay, so for this just let me show you the Mastercam interface with this pocket toolpath. As you can see that here is a already existing material. On this existing material I have to turn pocket. So for the pocket I have to choose this pocket, and by selecting the chain I have to select that chain, and at this time I have to remind that thing the arrow direction. Okay, so this is our toolbar type pocket. Coming to the next, in select library tool, suppose I have selected a flat end mill. Okay, according to your application you can provide your cutting parameters, tool parameters, and go to the holder, go to the cut parameters. Here you can see that stock to lever walls for the finishing purpose are. I just click on 00 because we don't need any finishing purpose. Okay, here, and here is the pocket types. You will get the pocket type standard facing. Go to the next roughing. In this roughing you will get some cutting methods like zigzag. Okay, I just select parallel. This is a step out percentage or step out distance. Okay. Come to the next. This is the entry motion, how it will be entry. And come to the next in finishing. If you want to do any finishing for the passes, you will provide, or you can provide that. And lead in, lead out. This is not necessary. I will tell you about this lead in, lead out, why we actually use that. And depth cuts 1 mm. Okay, keep tool down. Linking parameters die and clearance as per your requirement. Okay, top of stock already you have did that facing operation. And depth, for depth we have to select the depth or choose the depth. Okay, and okay, so as you can see, this is our 2D tool path. Okay, just let me show you how it cut the material. As you can see, as per our given depth of cut value, it will cut that material. Okay, let me show you in 3D motion. So for the 3D, we have to go for this verify, and you have to just start on play, and you can see how the material will be cut. Okay, so coming to the next operations is our contour operation. So for the contouring, we have to select the contour tool path. Here is the contour tool path, and by selecting chain, I have to select the channel for the contour operations. This is our chain. Okay, and after that you will get the same window. For the tool path, you have to select the contour, and I've selected the same tool, flat end mill 10 diameter, and go for the cut parameters. Here you have to define compensation direction on which side that will be go. Okay, and here is the stock to leave on walls, stock to leave on floors, and go to the depth cuts. Okay, keep tool down. Lead in, lead out. Here this lead in, lead out is needed. Okay, and if you need any multi-passes, then you can also provide that. Come to the next in linking parameters. Okay, just provide the value and depth. Okay, just see, because we did the cut parameters the right, and okay, so you will get the contour tool path. So after that we will go for the next operations is our drill. So for the drill we have to select the drill 2D drill tool path. Okay, and by selecting this mask on arc, we have to select just or find out the arc. Okay. After that, just drag on that and drop, and by selecting the order you can define the order. Okay, same as it is. Go for the tool as per your diameter. If there are any availability, then it will be easily identified. You will get there are a lot of types of tool, and this is our drill. Okay, 10 diameter, that is availability of the 10 diameter drill tool. And go for the holder, select the holder, stock, non-edit, cut parameters, what type of cycle you want. I want if you want a pack drill, then just click on the pack drill and give the pack value. Okay, and go for the linking parameters. Active the clearance and retract, and go for the top of stock and depth. How much depth do you want? As you can see, this is our depth, so I just given that, and okay, this is my until truth is generated. And so now I will show you the whole operations in a 3D simulations window. Okay, just click on it and regenerate all toolpath and go for the verify. And here you can stop condition, you can apply the stop condition by choosing the operation change, and you can also give the curl loop by operations and just start it. Just a minute, I didn't. Okay, now start. So first facing operation is done. Next is our pocket operation. Okay, and next operation is contour. Here you can see that in information. Okay, and next operation is our drill. Okay. So this is it, the whole operations. So how the NC codes will be generated? Okay. So for that you have to go to this post selected operation, that is G1 symbol, and click on that just, and click on the NC file and just click OK. After OK, you will get a window for saving file, the root file, root. Okay, after that just click on save, just replace it rather than previous operations, and you will get a Mastercam code export window, and here you will be able to find your ANSI codes. Here's the ANSI code generated. Okay, all the operation that you have done, you will get the all ANSI code very easily within a short time. Thank you.
Thank you, Akash, for this nice technical session. Everyone, yeah, thank you. Now we welcome you for your queries. Whoever has got any queries related to any technical areas or any area related to machine or uh, anything what during the session you might have come across, you can freely ask any of the query on that. Okay, thank you. For query, you have to just type in the chat box so that I will respond on that. Thanks. Yes, somebody has put a query that how ANSI codes can be connected to the machine. Basically, ANSI codes are not recognized by CNC machines, but then certain machines which are made on the principle of printer technology, those recognize such things. And the method of connectivity is almost same. You can either connect through Ethernet connectivity. You have option of RS-232 or RS your 9-pin connector or 25-pin connectors. So you have both the options. Or okay. Yeah, how to verify the toolpath which is generated? This is a very good question, because anything what we do must be checked. Okay, whether it will perform well or not. So it's a verification or simulation that we call it as a doing it in advance before actually cutting on the machine. So verification is something when you have a raw metal stock of specific size. So let's say a stock of 100 by 100 by 50 thickness, and you are cutting one core insert or cavity insert from that. So you on the software select such raw material stock, okay, and in verification, whatever the programs you have generated, so all such programs can be unmade. Okay. So all such programs can be simulated using Mastercam. And you can always check, even there are options to check how much stock is remained, which area cut, which area got overcut, which area got undercut. All such things can be covered in this area. Okay. Yes, yes. Yeah, 1 minute. Sir, I am connecting you to the entire group. 1 minute. आकाश स्काइप को हेलो हेलो हाँ आकाश हाँ 1 मिनट सर हेलो हाँ ये स्काइप को विंडो कैप्चर डिवाइस में लेना है वीडियो कैप्चर में वीडियो कैप्चर में ना ओके इसमें लेकिन वो डिवाइस जो है ना एक ही दिखा रहा है वेब कैम 2 दिखाना चाहिए ना उसमें ऑप्शन में नहीं वो ये सिलेक्ट नहीं हो रहा है उसमें ऑप्शन ही नहीं आ रहा है उसका वीडियो कैप्चर में स्क्रीन कैप्चर डिस्प्ले कैप्चर कर लेता हूँ फोटो आवाज़ नहीं आएगा मीडिया सोर्स में भी नहीं आएगा ना वीडियो कैप्चर में ही आएगा बस एक ही हम्म हम्म विंडो कैप्चर में हाँ इसमें आया स्काइप स्काइप 3 आ रहा है और स्काइप आ रहा है नहीं कैप्चर हो रहा है ना hello yeah HOD sir and Harne sir would like to say a few words with you Hello. I think, sir, your voice is not audible. 1 minute. I'll just.
आपण ज्या व्यक्तीशी बोलत आहात त्यांनी आपला कॉल होल्डवर ठेवला आहे. कृपया लाइन पर रहा. आपका कॉल
Hello.
होल्ड पर है. लाइन पर बने रहिए या कुछ देर बाद कोशिश करें. Your call is on hold. Please stay online or call back later. आपण ज्या व्यक्तीशी बोलत आहात त्यांनी
Yeah. So the collision detection, what is mentioned, like whenever the part collides with the unwanted parts of the tool, maybe unwanted in the sense we are expected to cut with the insert or the tip in case of turning, or the flute in case of the milling. So if your holder is cutting the part, that means it's collision. So that is called collision detection. Yeah, and Mastercam definitely detects that. And another query was raised that whether we can apply it for plastic parts or only for the metallic parts. So what happens is that Mastercam is a software which is for machining. So mold plastic components machining is very well possible. Like Sumi Badarsan in Noida, they are very much effectively using. Amphenol is using. There are many companies who are using for plastic component machining. So when you talk of plastic component machining, it is possible, but when plastic component molding, so what happens? Die and molds are used to be machined using CNC machines and Mastercam, and then you can get a mold which later can be machined. Sorry, the components can be produced on the injection molded machines. Okay, so now I would also like harnesser and to be live on this session. One moment. Yeah, can you listen can you hear my voice, sir? Okay, great. Yeah, 1 minute.